So we're looking at some identities. Let's take them as examples. Prove the following identities. One, or should we call it one, so that we have A. Oh, I like it in this form, one. So start with angles related identities. Tan pi over 2 minus x. So that this is just the same as cot x. How possible is this? So let's see. We'll put another one. 2. I'm sure that sine x. Sorry. Okay, show that sine x minus pi over 2 is equal to negative cos x. Okay, so let's see for these two. So say solution. For one, the best would be expanding tan. So how do we expand tan if we pick the left-hand side? So let's pick the left-hand side. So tan, we know that tan A minus B is the same as tan A minus tan B over 1 plus tan A tan B. So we have a question, tan pi over 2 minus x. This is the same as tan pi over 2 minus minus tan x over 1 plus tan pi over 2 tan x. Now pi over 2 is 90. So what is tan 90?
Math error.
Math error. So how do you move from here to the other side? So of course we know. So of course we know that tan 90 is sin 90 over cosine 90, and cosine 90 is 0, as sin 90 is 1. So we have undefined in this paper here. So the fact that it's undefined leaves us without any, so we can't move in this case. So if we can't move, then we notice that we have nothing to say this far, and we can't force it. You can't define it, can't do anything. So I'll move to second piece, sine x minus pi over 2. I also get the left-hand side. For this one, I'm not putting this definition because we remember it is just sine x cosine pi over 2 minus sine pi over 2 cosine x. But we know cos pi over 2 is 0. So we are dealing with sine x multiplied by 0 minus this guy here is 1 multiplied by cosine x. That means that we get negative cos x, which is our right-hand side. So where things work, we easily get the other side. And this is what you do even in an exam. You don't write anything. Like I've seen comments when you're marking and find the student is saying wrong question. I mean, why should you even mention such a thing? Just move steps. If you're so sure that you're in the right direction, you can either ask or move and leave it somewhere. Hello.
So for the first question, you cannot move from the right-hand side to the left-hand side.
We move from cot x.
Yes.
Suppose we did that. Our first step would be I don't think it's that possible because of the involvement of an angle. So we have no space. It will be hard for us to introduce an angle in a systematic way.
I see.
So someone is asking at where has cosine come from? Don't forget, we said this is sine A cos B minus sine B cos A. And we call them compound identities. Please don't forget the identities. You can't move in identities if you forget any of those that we discussed. Okay. Question 2. Prove.
Sir, sorry, the previous board.
Okay.
Thank you, sir.
Okay, so part 2, prove sine x over 2 is equal to plus or minus the root of 1 minus cos x over 2. Okay. So what do we do here? Remember this is a half angle. So we'll pick the left hand side. In a very special way. So instead of picking direct sin x over 2, we want to pick, the first thing that we should write is sin squared x plus cos squared x is equal to 1. First thing. Second is cos 2a is equal to cos squared a minus sin squared a. Now that we are dealing with sine, we need to change this piece here to sine. So we have cos 2a is equal to 1 minus sine squared a minus sine squared a. This is the same as cos 2a giving us 1 minus 2 sine squared a. And then we switch, or we take this one the other side, so that we have cosine 2a minus 1 is equal to negative 2 sine squared a. Divide by negative 2, divide by negative 2. So what we have now is sine squared a is equal to 1 minus cos 2a over positive 2. So this negative, I've divided it. That's why I've seen the 2 is becoming positive. The 1 is positive, and the cosine takes the negative. From here,
Sir, come from the top.
hello?
I'm saying I'm not following you.
Okay, Linda.
Yes, sir. I have a question.
Mm-hmm.
For example, this.
Which one? Let me break down. Okay. So look, when you're proving these identities,
A way which you have.
okay, let me restart. Let me explain. Maybe I'll catch you also.
Huh? Can't get you, sir. The network is dripping.
Okay, I'm saying let me restart. Maybe I'll pick you also somewhere. Okay, so the key thing when you're trying to prove the half angle identities, remember we did write the half angle identities when you're writing those compound identities in some lecture.
So is this the first question? Oh, so can I see the first board, please?
Is
this your first board or there's another one?
This is our
The
second.
first board or there's another one? The network is bad for me, so I was logged down.
So this is the first. The first.
Okay, let me take a screenshot.
Okay. Okay, so when you're doing half angle identities, remember we we wrote these identities somewhere in some classes that we had. So this is just a recap question. And this identity came after we wrote this one, the one we called the most important identity. Then we did the compound identities where you are saying, since we have said that cos A plus B is the same as cos A cos B minus sin A sin B, then we said if A is equal to B, then we'll have cos A plus A, which is going to be cos A minus sin A sin A. But A plus A is the same as 2A. And cos times cos is just the same as cos squared. Sin times sin is the same as sin squared. Okay, so all these came as identities. So we had this identity. We also had this as an identity. Okay. Now from this, combining this one with this one, where there is cosine here, we change it to sine using this identity. Remember, from this identity, we can say from this one, we can solve for cosine in terms of sine by taking sine the other side. It will go there as a minus. So if we pick this and substitute in this one where there is cosine, we're going to have this very cos 2a written as 1 minus sine squared a, representing cosine squared, then minus sine squared a. If you add these, you're going to get that cos 2a is the same as 1 minus 2 sine squared a. But if I have this one, I can choose to solve for sine squared a. So let's solve for sine squared a. So we'll take one the other side. We'll have cos 2a minus 1 is equal to negative 2 sine squared a. We can divide this by negative 2, divide by negative 2. So we'll have the sine squared has remained alone, equal to, the left-hand side here is cos 2a minus 1. So I thought maybe there was a question. Minus 1 over negative 2. But if you want, we can hide this negative by dividing it throughout in the numerator, so that we have sine squared a written as 1 minus cos 2a, and then leave the 2 as
Sir.
positive. Hello.
Sir,
Hello.
from where we had sine 2 squared equals to 1 minus cos 2a over 2. I don't understand how we've moved from there.
Where we had?
From where there is cos 2a, I get what you did there. Then there's sine 2a, sine squared a equals 1 minus cos 2a over 2. Now, these other boards, I don't understand. These other sides of the board.
So we are dealing with this side, is it?
Yes.
Is this where I don't understand?
How from where you drew that triangle, there I got again. Now, how you've replaced 1 minus sine squared a into that thing. I don't get.
So you are here.
Yes.
Okay. So look, what you are saying is, if you understand,
Sir, sorry. Also, how you got that's what you've just underlined.
ah, how do I explain this? Okay. Where do you start from now? Okay, so let me start from this identity here. Are you familiar with this identity? Remember, we wrote this as the most important identity. Sine squared x plus cosine squared x is equal to 1. Then we came back, when you're looking at identities, we came back and said, from this very identity, if somebody asked me for cos squared, I can take sine squared the other side, so that cos squared can be written as 1 minus sine squared x. From this very identity. Okay, now you keep this. Then we said, under compound identities, cos A plus B is the same as cos A cos B minus sine A sine B. Any questions? This part.
No, sir.
Okay. If where there is B here, we put A, we have A plus A. This means even on the right where there is B, we have A. Where there is B, we have A. We have A like that. A plus A is simply 2A. Cos times cos is cos squared A. Sine times sine is sine squared A. Our question here has sine. Now I want to answer our question. So since we have cos here, we also have cos here. This cos, we don't have a direct relationship with sine. But this cos, we have a relationship with sine. This cos squared here is what we have here. We have said that cos squared x is the same as 1 minus sine squared. So where there is cos squared, if you wrote 1 minus sine squared, you have not changed anything because they are equal. So where there is cos squared here, we want to write its equivalence 1 minus sine squared A. This is representing cos squared. But we also have a minus sign, so we put minus sine squared A. Any questions this far?
No, sir, but why did you replace B with A? To make the work easier, or you're supposed to do that?
No, we replace B with A because we want this identity here. So I'm moving from double to half. So if you look at our question has X, it also has X. It just has one variable. That's why we have decided to move with only one variable.
Sir,
Hello?
so why is it that we are not squaring the A? Since it's a cos A times cos A. So to be cos squared A.
It won't be cos squared A.
Sir,
A
I just
squared.
love
Why are you not squaring the A?
explain what you were just from explaining.
You guys, cos A times cos A is the same as cos A squared. But this can be written as cos squared A. A is an angle in cos. So what you are squaring is cos and not the angle in it.
So the cos 2A identity only comes about if the angle is half or something like that. When does it come in?
When you are trying to get to, it comes in so many ways, except that it's one of the rules that we use going to the half angles.
Okay. Okay.
So now we only have 9 minutes. So let's finish the identity. Let's try to follow Era.
So, okay, I'm not really connecting why we are driving these according to the question that you've been given. What's the connection?
Okay, so now you just hold a bit, you will see the connection. So if you look at this, it's the same as this one. So you can add them, we get 2 sine squared A. But this is the same as cos 2A. So let's switch. Let's take this, the other side, and then this guy, the other side. So that we have 2 sine squared A is equal to 1 minus cos 2A. You understand that if anything crosses the equal sign, it changes the sign. So cos 2A has crossed the equal sign, and negative 2 sine squared A has crossed the equal sign. That's how they change the signs. Then we divide by 2, we divide by 2. So that we remain with sine squared A is equal to 1 minus cos 2A over 2. So the identity is almost done. We just need 2 steps to the identity. So we let x be equal to so let 2a let x be equal to 2a. So when you reach here, then you let x be equal to 2a, so that if you divide by 2, a is going to be x over 2. So you keep this. Come back to the question. Since we have sine squared, if we square root, we are going to have sine A be equal to plus or minus the square root of 1 minus cos 2A over 2. Now, where there is A, we are saying it is the same as x over 2. So we'll have sine x over 2 is equal to plus or minus the square root of 1 minus, where there is 2A, we started by letting x be equal to 2A.
So where are the square root coming from?
We have square rooted because we had a square here. We had sine squared, so one just remaining sine. So we square root both sides.
Okay. Okay.
Okay, so now we'll have 1 minus. So where there's 2A, we say 2A is the same as x over 2. End of the identity. So we have proved that the two are equal.
Sir,
Hello.
so why did you make them cross there? You said this one will cross the other side. Why were they crossing?
So we are solving for sine. So we just have to make sine the subject of the formula. You can make it a subject in any way that you like. You can take one other side and divide by -2 and rearrange, or you make them cross so that you don't have issues with the signs.
So sir, it would have been okay if you just divided. Okay, I'll try it. Okay, thank you.
No dividing.
Yeah, I was thinking.
Sir,
Uh-huh.
we had x over first. How did the a come about? Is it that we had x over 2 is equal to a, then you cross multiplied?
Our first statement was let x be equal to 2a.
Okay.
Then so for a from that one, you get a is equal to x over 2.
Okay. Eco critical.
Hear it.
Sir, what happened to the 2 that was on course?
It has been replaced by x. Since we assumed that x is the same as 2a.
Mr. K,
Hello.
but look, if you are the one who's solving, because you even know when to make x to represent 2a, shani na shani, but us, it go crucial.
No, these are identities. So in identities, yeah, identities will need more practice because we have less reasoning to make in identities. They will definitely have to come the way they are. So when you're given a question to prove an identity, it's very hard for you to alter it in your own ways. Normally, we need to relate to the original way it was introduced. Remember, when the guys were coming up with these identities, they tried so many methods and then arrived at such equalities. Then they called them identities. An identity is something that has been proved already. Yours is to follow the proof. You just help yourself understand how easy you can remember what they were doing. This is an already done work. Our job is to understand what was done and find easy ways of remembering how they were doing it. So that in case you're asked to redo that thing, You must do it in the same way they did it. And these are the procedures. Because we have less reasoning when it comes to how does this come about? I mean, who can answer that question? The only thing is, I mean, how does this come about? We have so many questions to answer. So to avoid that, we get this as a proof, I mean, as an identity. Next, pick this as an identity. Then now, using what we know, we can now start solving, getting to this one. Catherine?
Sir, there you equated x to x, you equated it to, okay, you equated a to
X to
x
2a.
over 2.
X to
Yes.
2a.
Okay, and then you replace it
No,
where
and then
there's a.
no. X to 2a, and then you solve for a. A became x over 2. So where there is a, you take x over 2. Where there is 2a, you take x.
Yes, so now if you take x over 2 where there's a, why isn't the 2 cancelling? It won't cancel.
That's why we only have x.
Oh, okay.
So let's log out and
Thank
come
you,
back.
sir.
All right.
Sir, excuse me, sir.
Time out.